Hi, this is Jeff Spencer, Math 135 instructor, and this is our lecture over section 5.2, which is the second section in probability. It covers the addition rule and complements. So we're looking still at, when we talk about the addition rule, the key word is or, and we're still talking about making one selection or one trial of an experiment. Complements are to the same thing, one trial or one experiment, or one trial of an experiment. So we're going to learn about the addition rule for disjoint events, learn about the general addition rule, and then compute probabilities using the complement rule, which is pretty easy. So let's use the addition rule for disjoint events. So we say two events are disjoint if they have no outcomes in common. Another name for disjoint events is mutually exclusive. So when I roll a die, I can't roll an even number and an odd number at the same time, so we say those are mutually exclusive. When I flip a coin, I can't get a head and a tail at the same time, so those are mutually exclusive. If we ask for the probability of selecting a red car or a green car, those outcomes are disjoint, so we can't have both. We can't select a red and a green car at the same time. Don't worry so much about the Venn diagrams, just pay attention to, for this example, suppose we, starts right here, suppose we randomly select a chip from a bag where each chip in the bag is labeled 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have the numbers 0 through 9. Let E represent the event. Choose a number less than or equal to 2. So that's this, 0, 1, 2. And F represent the event. Choose a number greater than or equal to 8, which is 8 and 9 because the sample space is up to 9. So these events are clearly disjoint. E is the events 0, 1, and 2, and F is the event 8 or 9. So let's imagine that you are playing a game in which you draw a chip and you win a prize if you draw a 0, 1, or 2, or an 8 or a 9. These events are disjoint. They can't happen at the same time, and the probability of that, we're going to just add them to do that, to figure out the cumulative probability. So the probability of event E getting a 0, 1, or 2, a number less than 2, is 3 numbers. There's 3 numbers out of 10 total numbers, 0.3. The probability of F getting an 8 or a 9 is 2 out of 10. There are 2 numbers out of 10. So then what we do is we just add them up together. They're not showing this math here, but 0.2 plus 0.3 is just 0.5. Or if you look at it, there are 5 different numbers out of 10 that satisfy getting a 0, 1, or 2, or an 8 or a 9. So there's the addition. The 0.3 plus the 0.2 is 0.5. Okay. So generally speaking, if any events are disjoint, mutually exclusive, meaning they can't happen at the same time, then when we want to find the probability of the first event or the second event, we just add that. So the key word is or. Let me remind you, a big point is that when we use this word or, we're talking about making one selection. Can we get this event or that event to happen? And we just add up the events, or the probabilities of those events. Same thing, if we have multiple events that are disjoint, more than just 2 events, then we continue to add their probabilities no matter how many events there are. As long as they're disjoint, we can add their probabilities. So that's what this is saying down here at the bottom, and this gives a good example. So the probability model to the right shows the distribution of the number of probability distribution of the number of rooms in housing units in the United States. So there's about 1% of the housing units have 1 room. There's about a 3.2% that they have 2 rooms, 9.3% that they have 3 rooms, and so on. So they want to verify that this is a probability model. So each probability is between 0 and 1, and it should add up to 1. Part B, what is the probability that a randomly selected housing unit has 2 or 3 rooms? 2 or 3, so those are disjoint. You can't have 2 and 3 rooms in a housing unit. You either have 2 or you have 3. So we're just going to add the 0.032 and the 0.093 and get our cumulative probability. What is the probability that a randomly selected housing unit has 1 or 2 or 3 rooms? So 1 or 2 or 3, those are disjoint once again, so we'll just add those 3 numbers and get 0.135. The general addition rule applies to all events when we use the word or, but not necessarily every event is disjoint. So we have this second part of the formula here where, yes, we're going to add up the probabilities of each event, but then we have to subtract off what I like to call the overlap, the part where both events can happen at the same time. So this is for all events, whether or not they are mutually exclusive or not. If they are mutually exclusive or disjoint, the probability here at the end is 0. So this is a good example. It says, suppose that a pair of dice are thrown. Let E equal the first dice is a 2. The first die, excuse me, is a 2, and F equal the sum of the dice is less than or equal to 5. Find the probability of E or F using the general addition rule. Well, here is the 36 different outcomes when you roll the die. And if we look at the event E, the first die is a 2. So that would be this one. There are 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. So if we looked at the probability of E, which they'll show here in a minute, it's 6, these 6 events out of 36. That's what they're showing there, the probability of E. Now, the second one, let F equal the sum of the dice as less than or equal to 5. Well, the sum of the dice less than or equal to 5, well, here's the sum of 5, here's the sum of 5, here's the sum of 5, and here's the sum of 5. So we have those 4 events, and then every event to the upper left of that has a smaller sum because the dice are smaller. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 events, these 10 in the upper left-hand corner, that are where the sum is less than or equal to 5. 10 events. And that's what they're showing here, 10 out of 36. Okay, and then they reduce the fraction here. All right, but when we counted these 6, the first die is a 2, 1, 2, 3, 4, 5, 6. We counted these 3 events, the 2, the 1, the 2, the 2, the 2, and the 3. We counted them twice when we looked for a sum less than or equal to 3. So that's going to be the overlap part, the part where the event E and F happen at the same time, where the first die is a 2 and the sum is less than 5. Those are those 3 dice. Let me show you again, or 3 combos. This one, and this one we already counted. Those 3 have both the characteristics. First die is a 2 and the sum is less than 5. So what we have to do is take this number, add the 6 over 36 plus 10 over 36, and subtract the 3 over 36. I don't know why they're reducing it. Ignore the 1 6, 5 18ths, and 1 12. So if we take the 6 events that start with a 2, the 10 events, the 10 die combos that have a sum less than or equal to 5, and we subtract off the 3, then we get 13 out of 36. And that's how we use the general addition rule. So we add, anytime we see the word or, we add, and then we subtract off any overlap. In this case, there were 3 events that had both that we counted twice. Alright, the third objective is to find the probability of an event using the complement rule. So if we want to find the probability of a complement, we just basically do 1 minus the probability of that event. So complement just means not that event. So let's look at an example here. They're saying E is the event, E complement is everything but that event. So if it said, according to the American Veterinary Medical Association, 31.6% of American households own a dog, what is the probability that a randomly selected household does not own a dog? So keyword does not. We know the probability that somebody will own a dog, so we just take 1 or 100 minus that probability of somebody owning a dog. 1 minus 0.316, 0.684, or 68.4%. So that's pretty much it for complements. Complement just mean the not of that event, and to figure out the probability, you just do 1 minus that, because the sum of all the probabilities has to add to 1. So that's pretty much it for the general addition rule and the complement rule. I have a video with examples, which I'll attach next to this reading assignment video. So see you next time.